We complete this segment with two other concepts that are fundamental for scientific programming. The first one is the concept of missingness, and then we'll deal with random values. So very often in when you deal with data science, you have some data that is only partially known. So some values are the value of some variables is unknown for whatever reasons, and it's important to distinguish this case here from the case where we want to say that this something is not defined or shouldn't have a value. In case of in the first case is the data science point of view, we really have something that is missing. That we know that should have a value, but simply we don't know it. In the first case, in the second case that here is represented as the first case, instead we have what is called a software engineer's rule. And the main difference, so in Julia we have these distinctions, and we have also a third case where we have not a number, the concept of the result of some operations that is not defined as a number. The difference between these two cases is that the first one, when we deal with something that is nothing, with the keyword nothing, with the singleton instance of type nothing. So the type is with capital N is nothing, and this type here has only one instance and is called nothing with the lower n. The same things with missing. Missing, the type of missing is capital M. Missing is the type, and by conventions, the types are written with capital, starting with a capital letter. So the first one, there's nothing here. If we encounter here, if we do some operation with something that is nothing, we end up with a runtime error, because it's not a situation where we would like what we should be. We always have to do with some deal with some objects. If we have nothing, it signals that we are reaching a condition in our program that is not a state in our program that is not the one where we should be. Conversely, with missing, we may well have a situation where we have missing data, and in that case, what we do is that it propagates silently. So if we have, for example, so we have A and B, okay, and if we make and C, and as I said, the type is nothing and missing with capital M, while for not a number is indeed the same kind of a float, and we can obtain, for example, when we divide 0 by 0, we have not a number. Now, as I said, in the first case with nothing, if we make an operation with nothing, we would have an error. So here we create a mean of 1, A, and 3. And indeed we return, because we don't have an operation to add nothing to a float. When we have instead a missing, what we'll have? 1, B, and 3, where B is a missing. We cannot say. We have some data, because B, we don't know if it is large or small. So the results of an operations is itself, even if there are 100,000 values, and then we have one single missing, the result is a missing itself. And the same with not a number. not a number propagate itself. So if we do an operation we are not a number, we have a not a number as an output. If we want to do operations with missing, we have two alternatives. Either we assign missing in a certain way. So we will see, for example, we have a machine learning algorithm that impute the missing. Sometimes it can be very simple. What we have in our data as missing is indeed a 0 or a 1. It depends on your specific context. It's not something that the programming language can tell by yourself. So sometimes you know that when you have missing data is a 0. So what you do is simple. You impute the missing to become them 0, or you can simply with this function skip missing. Even if there are missing value here, they are just skipped before the operations happen. So here we make min to an array that is reduced from the missing component. And what this does is make a min of simple 1 and 3 without accounting for the missing value. So if we have this missing here, we can check if it is missing with is missing. We cannot say missing, we cannot say something like b equal missing. What do you think will happen? We don't know. It's a missing, so it propagate. We have a missing results. We don't have neither a true nor a false, because we don't know what b actually is. So if you have an array where we contain missing data, we see here that automatically we have a vector of what type? We don't have a type integer, but a type where we have a union of missing value and integer value. So type of before is our vector, and L type is the inner type of the vector, and the inner type of the vector is a union of missing and integer. If you want to say, if we want to check which is the type of a union of missing and something else, and we want this something else, we want this integers, what we do is we ask for non-missing type of our object, or in this case of the inner type. So here we have integer 64. It is very important to keep the distinction between the software engineer null that rise runtime error, and we should be very scared if we have it, and missing that mean that we don't have information about this specific value, and all operations with this where missings are involved, unless we deal, and this is the important matter, if we have some missing, we need to if we have the possibility of missing data, it's up to us, the programmers, to organize our code as a function of this possibility of missing data, rather than having this missing data to account silently in our results. It was we are in the COVID period, in the COVID era, and I remember there was some problem with some results where there was some data that was missing, and this was not realized. In other systems didn't realize that some data was missing, and this created some error in the output of whatever was the procedures. And instead here in Julia, if it happens that you have some missing, even if it's only one, your output will propagate and will be a missing, so that you will really see that, and it's up to you to take the correct actions for your situation.